Let's say there is a resultant force going in the positive vertical direction with 500 newtons as the force. So what we can start out doing is we can write F sub r is going to be equal to 500 newtons. Now, what we want to do is we want to find the magnitude of F as well as the direction of F, or essentially theta. So what we can start off by doing is we can take the summation of forces in the x direction, taking the right as our positive direction. So we can start off with this force on the left here, the 700 Newton force. So that's going in the negative x direction, or to the left. So we're going to say it's negative 700 newtons times cosine of 15 degrees. And the reason we're doing cosine of 15 because we want to take this horizontal component of that force. And then what we'll do is we have to include our f here. So we're going to have plus f times cosine of some angle theta. And now that is going to be equal to 0. Now, what we can also do is we can take the sum of forces in the y direction as well. And then we can take the positive direction as going upward. So now we can start off with that 700 Newton force again. And since it's going downward in its y direction, it's going this way. So it's going to be negative then. So we're going to have negative 700 newtons times the sine of 15 degrees. And then we're going to have plus our force that we're trying to find times the sine of theta. And then instead of doing 0 here, now that we know that we have a resultant force, or essentially a force left over, so we're going to want that to be 500 newtons in the positive y direction. So we're actually going to put 500 newtons instead of 0 here. Now, what we can start off doing is we can try to get our forces essentially on one side. So we can write this as, let's say, F cos theta is equal to our 676.15 newtons. And that's essentially taking this negative 700 newtons times cosine 15 and simply just adding that to the other side and then evaluating it. And then what we can do for our summation of y is, for this we can say that F sine of theta is going to be equal to, so we're going to take our negative 700 newtons times sine of 15 degrees, and we're simply just going to add that to the other side. And then what we'll get is we will get 681.17 newtons. So now what we can do is we have two equations and we have two unknowns. Now one thing that's kind of neat, so instead of, let's say, dividing by cosine or dividing by f and then trying to substitute, we can get a little bit clever here and we can actually use trigonometry to help us solve this. So we can start out by saying f of sine theta divided by f of cos theta is going to be equal to 681.17 newtons divided by 676.15 newtons. And now what we can do, now that we have a fraction, is we can actually cancel out our forces here, and then we're left with sine theta over cosine theta, which just happens to be tangent of theta, which we can then say is going to be equal to our 681.17 divided by 676.15. So now we can actually solve for theta by doing theta is equal to tangent inverse of the 681.17 newtons divided by our 676.15 newtons. So then we get that theta is approximately 45.21 degrees. So now we have one unknown, so now what we can do is take one of the equations from before. It doesn't matter if it's the f equals, or f sine theta or f cos theta. I'm going to use the f sine theta, but either or would work. So we can essentially do f sine theta is equal to 681.17 newtons. So what we can do is we can then say F is going to be equal to 681.17 newtons divided by sine of theta. Well, here theta is 45.21 degrees. So then we get that our force is going to be equal to 959.74 newtons. And that's all.